Okay, so let's get going here. So assignment number 4 is due on Wednesday at noon. Assignment number 5 is all written up, and I will post it after I get done grading assignment number 4. Before we get going here, just a few small announcements. So a little bit of a follow-up to Leanne Marshall's visit to our class a couple weeks ago. She said that for new graduates with a master's degree who are interested in that industry that she works in, a starting salary for this part of the country would be about $60,000 a year to expect, where you could earn a lot more if you went to the East Coast or the West Coast of the United States. She still hasn't gotten back to me regarding who to contact for an internship at First National Bank. Also, maybe you've noticed this, there's a nice little salary survey that's available on the AMSAT News website. The latest salary survey for people who are interested in government or industry work is available. And they give some interesting ranges for salaries. This is useful, but especially for someone who's just beginning a new career in terms of like a starting salary. This doesn't give you information about, okay, this is what I should expect if I start to work in government right now. But at least it gives you some ideas of what statisticians are making with a variety of different years of experience. Maybe they do, yeah, I mean, they do give some information about, maybe I kind of misspoke there. They do give some information about salary for if you're just beginning a career as a statistician, but it's not necessarily specific information, as specific as maybe what one would like. So anyway, maybe you might find that useful. Okay, are there any questions before we get going here? Okay, we're going to try to quickly finish up this section on conferences. So we've talked about the joint statistical meetings. We talked about the ENR meetings. Those are the two largest conferences in the United States and Canada every year. And those are run very well, from the beginning in terms of submitting your title and abstract to finding out when you will present to the actual conference itself. They, in terms of actually being there, they're typically held in city's largest convention centers that they have available, or in some of the best hotels that they have available. Not all conferences are like that, especially in some respect. The smaller the conference gets, the more likely the conference will not be, let's say, as desirable in terms of where it's held, the facilities where it's held at. I mean, it still might be very useful, but it's not necessarily as desirable, the facilities and stuff. Doesn't mean all small conferences are like that, but some do. In particular, for example, the WENR meetings. Does anyone remember what WENR stands for?
Western North America region.
Very good, yes. With the Western North American region of the International Biometric Society. These are much smaller meetings than ENR. I've been to a couple of them. One nice aspect is that they can be within driving distance of Lincoln. There's been a few in the Denver area. And so they have all the stuff that ENR does, but just a smaller scale. They don't have a career placement service available. Make this bigger. And this is an example of what happens often with smaller conferences, is that they typically hold the conference at a university itself. So imagine having a conference over in the East Campus Union over there. That's essentially what it was like a few years ago when I attended one at the University of Hawaii. Just to give you an example of, I think there were some issues with the facilities that they had. So on the last day of the conference, I gave an actual presentation. No, I don't know why I said actual presentation. I gave a presentation. So imagine this is the layout if you're looking from above of a room. So here is a podium that you can present from. Here's a screen. And the layout of the room that I actually presented on was actually meant to be two rooms where they had a temporary where normally they would have a temporary wall there. Well, they took the wall out so that more people could fit in there. But, you know, they have this, here's the projector there, and they have this very small screen up there, and so that people who were back here couldn't really see what was actually being presented. That's what I'm talking about. The facilities are not necessarily always the best at some of these. And so we were at the, so this was at the University of Hawaii and their student union. But just to show you the facilities and maybe some of the other stuff there, I had to walk up to the top of what's that called?
Diamond Head?
Yes, thank you. Diamond Head, so I give a picture of the facilities where the conference was at, right about there, and you can also see other very beautiful things too that was going on. Anyway, do know when you go to a conference, you don't have to spend all your time there. It's okay to take a little time off and explore. Okay, so there's also a Use R conference. It's about 10 years old. Obviously, ours is still fairly new, so the conference isn't that old. And it's growing in size. I've only been there once, but I've been wanting to go back. I just haven't been able to figure out how to make it happen. An even number of years, it is located in the United States. Odd number of years, it's in Europe. So let's see now, where is it going to be next year? Gosh, I don't remember now. Sorry. I know last year or this year it was actually at Stanford. Previous year it was in Denmark. And one of the nice things about this is the conference is typically held at universities, yes, but it's lower cost, and there are free short courses with that conference. The Statistical Society of Canada meetings, a little bit bigger than the WENR meetings. You might be wondering, why am I mentioning this? Well, it can be somewhat close to us. In the upcoming year, it's going to be up in Winnipeg, which is actually within reasonable driving distance to us. You have about 300 or so people. They're held on college campuses. This was at Brock University last year, so it begins the day with in a big hall where you have a keynote address. And this is another example of what I mean by the facilities are not necessarily always the best. This was actually, I think, in a kind of a student union area. This is actually where I gave a short course at the meetings, and you can see that I have this very small screen here that people were supposed to see what I was presenting. If you use a standard size font for any kind of presentation, similar to what I'm using here, it was difficult for people who were back here to actually see what you were presenting. And in fact, look at this right here. They even have an overhead projector. I didn't think they had those in rooms anymore, but if you wanted to use an overhead projector, you could. There was no lectern to stand at. You could put this up there, though, but it wouldn't hold my laptop very well. Anyway, enough about that. Again, the main thing that I'm saying here is that not all conferences are equal. The International Biometrics Conference is held by the International Biometrics Society every other year. Last year was up in Victoria, BC, and I actually went up there. The facilities that they have these conferences now are typically the convention centers. So here's a very nice, that's actually the main hotel that they had in Victoria, but the convention center was right behind it. That part of the conference was well organized. The beginning part was not, in terms of, it wasn't until about 6 weeks beforehand that I knew when I was presenting, and I couldn't make my plane reservation then until I found that out, because I needed, I couldn't stay for the whole conference because the cost was just too much. And so I had to wait and wait and wait, and they kept on saying, oh, we'll let you know by this date. No, they don't. And now we'll let you know by this date. No, they don't. And anyway. Does anyone remember what ISI stands for? It's one of those professional societies.
International Statistical.
Close. International Statistical Institute. Okay. Their meetings are called the World Statistics Congress, and you can see by its size it is pretty large. every other year. In 2017, it's going to be in Morocco. They organize stuff well. I went to it a few years ago when it was in Dublin. It's a really interesting looking conference facility that they have there on the River Liffey. Lastly, for those of you who are interested in teaching statistics, the number one conference to go to is the Joint Statistical Meetings. The number two one, and this is still a good one, is the United States Conference on Teaching Statistics. It's been held now for about the last 12 years, every other year. They typically also have them on college campuses. So, for example, I attended it once when I was at the Ohio State University. You even got to walk into their stadium there too. It has good attendance. They focus really on undergraduate education at this conference. And while I don't necessarily teach undergraduate classes in statistics, I found this to be still very useful because I get ideas from that for my own teaching of graduate level courses. So, for example, here's a picture of myself and, again, Chris Malone, my friend from Winona State University, giving a mini short course at this conference. I guess very lastly, Kansas State University does have an annual conference that has about 100 to 200 people every year that focuses on statistics and agriculture. Okay, are there any questions? Okay, let's move on to ethics. So I found constructing these lecture notes interesting. I have always thought that I am an ethical person. The choices I make, I think, about the consequences of those choices. Is it right? Is it wrong? And there's been a number of times in my career where I have come to a question of, okay, I'm not going to do that because that would be unethical. Coming into this, writing up these lecture notes, I was like, well, what should I put? And so I did a little exploring, and I found out, and I didn't know this before, that the American Statistical Association actually has a set of guidelines on ethics that all statisticians are supposed to follow. A lot of these are, what's the word? Obvious, but some are not necessarily as obvious, and it gives a nice set of guidelines to follow and kind of reminders of how to be ethical in your job. The International Statistical Institute, go away. There we go. Also has a set of ethical guidelines as well, and they really, especially obviously outside the United States or other well-developed countries, not necessarily even that, at least outside the United States. There have been a number of instances recently where statisticians have basically said no to people in government due to various ethical considerations. This happened in Argentina recently and also in Greece. Both are tied to the various economic problems that those countries have had. And I believe in Argentina, even a statistician was put in jail because, if you think in terms of official statistics, where you need to say, okay, this is greatly simplified. The economy is growing at 4% per year. Well, the unethical government officials might say, hey, you shouldn't say 4%. Can you say 6% instead? That will make me feel. That would make this person maybe more electable when they come up for a re-election. And so these people in Argentina and Greece were faced with those kinds of ethical dilemmas, and they basically said, no, I can't. I have to do what the numbers actually say. And so anyway, so the ISI has actually went to bat, you could say, to try to fight for these people. And I had hoped to talk about those stories a little bit more, but there's just obviously a limited amount of time that we have, so I chose not to. But anyway, if you're interested, I recommend doing a little bit of a web search to find out more about these problems that have occurred over the last couple of years. Okay, so let's talk about. So what I decided to do was focus on certain area of ethics that, in particular, are important for students to know right now. And the first one deals with plagiarism. Obviously, you've heard about plagiarism for a long, long time, and you know not to do it. But let's take a look at some examples with respect to statistics. And I wouldn't be surprised if some of them you might be thinking, oh, I didn't know that would be plagiarism. Okay. So here's an example. So if you remember from the very first seminar of this semester, I do my research in an area called group testing. And so what I have found is some examples of plagiarism in group testing. And also, I have some examples here of how to avoid plagiarism. And this example that I'm focusing on here actually talks about an introduction to what group testing is. And so I want to give you a real brief introduction myself, and then I will show you some examples. Okay, so one place where group testing is used is with respect to screening blood donations. The American Red Cross, when it screens for HIV, hepatitis B, hepatitis C, and West Nile virus, for every blood donation that they get, they need to determine, well, is that those viruses in the blood? So obviously, if it is, they don't want to give it to someone who needs the blood. Okay, so they need to, throw out, let's say, the bad blood donations. And so the way that or you might think the way that they would do that is that they get a blood donation, maybe take a specimen out of it, and then immediately test that one blood donation for HIV. And then they get a new blood donation, immediately test that one blood donation for HIV. They don't do it that way. Instead, what they do is that they get specimens from 16 different blood donations. They put these specimens up together. You can think of it maybe like a small cup to make it simplified. And they mix it up really, really, really good. And then they perform one test on that pooled or grouped specimens. The reason why they do that is because if it comes back negative, if you apply a test to that pooled specimen, if it comes back negative, then that means all 16 people don't have that particular disease that you're testing for. So it only took one test to determine that 16 people don't have a disease versus 16 tests to determine 16 don't have a disease. Now, if it comes back positive, then there's a variety of different ways that you could approach to determine who has the disease and who doesn't. A simple way would be to actually retest every single specimen individually, or every single blood donation individually, and take new specimens out. Group testing works when the prevalence of the disease is small, like HIV. In the United States, it's way under 1%. And by it being small, then the majority of those groups, that 16 people in it, will test negative. If instead you had, let's say, a high prevalence, then you're in danger of having lots of group tests positive and doing lots of retests. So group testing works great in a situation where you have an infectious disease that has low prevalence. Okay. Group testing is used in a variety of different locations, not just infectious disease testing. In particular, for example, with respect to mosquitoes and detecting the prevalence of, or detecting, we'll say the prevalence of mosquitoes carrying West Nile virus. So here's an example from Ebert et al. Look at the year here, 2010, where this is at the beginning of a particular paper, and they're trying to say, what is group testing and why is it useful? So I'll just read part of it. In practice, pooling, group testing, is a simple process. If 30,000 mosquitoes are collected from the field, they can be tested one at a time for a viral pathogen, like West Nile virus. If each test takes 10 minutes and costs $15, then the project will take 5,000 hours and cost $450,000. A shorter approach would be to smash 10 mosquitoes together. I don't know if I would use the word smash, but that's what they chose. Smash the 10 mosquitoes together and test this pooled sample. So typically what's done in practice is that with these mosquitoes, you could take it even like a mortar and pedestal. You smash up these mosquitoes so you can't tell them apart. and then you perform one test on that smashed up group. This approach would take just 500 hours, because you're doing 10 mosquitoes at a time, and costs just $45,000. Okay. So let's take a look at this other paper from 2012. Let's see if I can get both of them at the same. Let's do full screen. There we go. And let me get a highlighter out. I have to remember how to get a highlighter out. No? I'm sorry, I haven't used this particular version of this software very much. No. I'll just do it. Okay. In practice, pooling is a simple process. For example, if 40,000, well, that's good. It's not, at least it's not 30,000. Plants are collected. So this is actually a different application. They're applying pool testing to plants rather than mosquitoes. Are collected from the field. They can be tested one at a time for detecting unwanted transgenic plants. That AP there is just an abbreviation for, it's not a reference at all. It's just an abbreviation for what these transgenic plants will be. Basically, for example, with respect to, I think it's, what's the, I can't think, I think it's a Monsanto product. It's a certain kind of like corn that they have where they've actually put in the essentially the pesticide inside the corn, and basically what has been often a concern is that these doing a poor job explaining this. Basically, genetically modified plants, companies actually own patents on them. And somebody can't just, let's say, go to a cornfield that has a genetically modified plant, take a kernel of corn off it, and then go plant it at home. Okay? And so these companies are actually very, very interested in determining if somebody's stealing, essentially, their own, basically, genetically modified plants. So anyway. So if each test takes 15 minutes and costs $12 US, if each test takes 10 minutes and costs $15, then this project would take, and so on. A shorter approach would be to smash 10 plants together. A shorter approach would be to smash 10 mosquitoes together. Okay. I think you get the point. The second one's plagiarism. And you might be thinking, oh, yeah, okay, I see. Yeah, this is a direct quote. That's plagiarism. But it's not just that. They are using the same ideas, while they might have a few different words. They're using the same ideas to formulate their own idea. That's plagiarism, too. Okay? So how do you avoid plagiarism? Obviously, use quotation marks when needed. Okay? Also, you need to actually cite the work, too. So if you're getting an idea from somebody else, you need to say, basically, this comes from this paper here. You need to actually say that. And this includes even when you're paraphrasing somebody, or some other paper, or some other book, or some other resource. And I bring this up, obviously most of you right now are not writing statistical research papers. But this is just a good example where this occurs. But if you did this also with a homework assignment, this would be plagiarism too. So could one simply fix, get out of that, could one simply fix the excerpt in that second paper by using quotation marks when needed, by citing that first paper as well. Yes, but most likely this paper would not be accepted by a journal, because they might be wondering, why do you have all these quotation marks all over the place? Can't you come up with ideas on your own? So yes, it could be fixed by simply putting quotation marks and citing sources, but it wouldn't be accepted. So I thought I'd take a stab at it to see if I could essentially take some of the ideas that second paper was trying to do and write it in a way where I wasn't paraphrasing, I wasn't quoting. How could I do it? I thought about just reading this in class, but I don't think it's really worthwhile for me to read in class. But what I want you to do is after class, read how I approached it here and compare it to that second paper, where this is not plagiarism. Now, one, as I say here, one may be concerned is that I don't cite any sources in my write-up. And part of the reason is because a lot of people know what group testing is already. So that's why I thought, okay, I don't need to cite a source. But if one wanted to, and you will see this done in my area of research, one would often cite the very first paper on it, where the whole idea came about for group testing. Not that first paper that we saw, but the original paper where the idea of group testing came about. Now also I decided to go further, and again, I don't think this is necessarily something for me to read to you in class. I think this is something where you can read it to yourself after class. I write a lot of papers on group testing. I cannot introduce group testing the same way every single time. So I have to come up with my own unique ways of introducing it. And so what I decided to do was show you excerpts from 3 of my papers and a grant application to show you how, even though group testing I'm talking about group testing in every single case, I talk about it in a different way in every single case. Now, you might be wondering, though, well, why can't if I write a paper, why can't I just use that same introduction to what group testing is in another paper? Because after all, I'm writing both papers. You can't plagiarize yourself. Actually, you can, which is a weird concept. I've run into PhD students that I've worked with, and what has happened is that they will, their first paper that they're writing with me, they look at a previous paper that I wrote, and they basically take that and just put it into their own paper and change a few words around. Because they think it's okay to do, since my name will be on this paper that the student's writing. But no, that is still plagiarism. You can plagiarize yourself. Well, why? First of all, most papers written in research journals, not just in statistics, but all of them, the copyright is not owned by the person who's writing the paper. It's owned by the publisher. So any paper that I get accepted by JASA or Statistics in Medicine or Biometrics, I have to actually sign a release of the copyright to the publisher. Otherwise, they're not going to publish it. To some respect, for those of us in academics, that really frustrates us, because after all, we're the one who's contributing. We're the one who's doing the research and stuff. Why do I have to share? Why do I have to give the copyright away? There are some open access journals that are published free, where you don't have to pay for anything, where you can still keep the copyright. But at least in statistics, there's not that many of those journals. But even if you did keep the copyright, still, you have to ask yourself, why would a journal publish a particular paper where you basically are saying the same thing that you've already said before? And so that's why still you wouldn't do that. You would not introduce group testing the exact same way in another paper. But when is it okay to even go word for word from something else that you've written in the past. There are specific cases. One, suppose you write a dissertation, and typically the layout of a dissertation in statistics is Chapter 1, an introduction. Chapter 2, 3, 4 are papers that can be submitted to journals, as is. And Chapter 5 is the conclusion. Well, these papers, Chapters 2, 3, and 4, you submit it to a journal. The exact same thing that's in your dissertation. And so, yes, you can do that. That's okay. That is legal to do something like that. Another case, and I mentioned this a little bit when we were talking about conferences and the proceedings for the joint statistical meeting. So, many conferences have a proceedings. It's kind of a record of, okay, this is what was presented. Person presented something on, let's say, group testing. And to go along with the presentation, they have written a corresponding paper that's published in the proceedings. Now, typically, most proceedings will allow you to still try to go get that published in some other source that is actually peer-reviewed. But you have to make sure you talk to people who are in charge of the proceedings to make sure that that is possible. Okay. Now, the Office of Graduate Studies here has a nice set of web pages that talks about plagiarism. Again, this is not something I'm going to read to you. Instead, I want you to take a look at it on your own. I have a screen capture here that shows really the main thing that they have that I think is useful, where they have some original text, and then they show, well, what's unacceptable, what is acceptable, and where they use paraphrasing and also paraphrasing with quotations. So please take a look at that. So I think this then gets us to a good part here where we talk about, well, how do you cite somebody else's work, paper, book, or maybe even just a website? How do you do that? There's not a set way in the statistics literature that's used. It's very like journal dependent, publisher dependent. The most common way that you will see people, though, do a citation is similar to what I have here. So I have in-text or a parenthetical citation. So, for example, a few years ago, I wrote a paper that appeared in Chance. You remember what Chance is? It's kind of a magazine published by the American Statistical Association that's meant for a general audience, where you can have some fun with it. And so here's an example of how I talk about a particular paper that I wrote. Builder 2009. So the paper was published in 2009. I was the only author on it. Shows how group testing could be used to detect Cylons on the TV show Battlestar Galactica. So that's how you do a simple citation. Then eventually you would have a bibliography where you actually give the full reference of that particular paper. Let's say if there was two authors, and then you might say Builder and Tebbs. For example, my friend Josh Tebbs at the University of South Carolina, and you might say something like this. If instead, let's say there was 3 or more authors, this is journal dependent, but this is the way it's mostly done. You would do something like this. Builder et al. I believe et al. Is a Latin phrase for meaning and others, and you just do it that way. Now, there are times where you want to do a reference more in a parenthetical context. So, group testing has been described in a number of settings, including Cylon detection on the TV show Battlestar Galactica. Where was this done? Parentheses, Builder 2009. Some journals will want you to put a comma there, separating Builder from 2009, but some don't. So that's how you make that citation. Of course, always include the corresponding paper or book or wherever in your bibliography. There will be times where there's not a bibliography, though. Well, and you still want to cite. Well, what you can do is include the author's name and then put the actual journal or publication inside that parentheses with it. Okay. Now, Statistics in Medicine is, I think, the only publication that I know of in statistics that does this, but you see this more prevalently done elsewhere. Rather than saying, let's say, Builder 2009, they will actually have all their references numbered in the bibliography. And so then you would cite it using a bracket, the reference number in bracket. But that's the only journal that I know that actually uses that in statistics. It's more prevalently used elsewhere. Okay. So that's a short discussion on plagiarism. Are there any questions? Yes.
What about if the professor leaves an institution? Does the institution own the research, or does the professor?
The professor does. Well, the publisher owns anything that's published. And the publisher will give the professor or researcher certain rights to it. To, let's say, post the paper, not the version that's in the journal, but post the final submitted paper on the professor's website.
But like the university, if they funded your research, they don't own.
They don't own anything.
Okay.
The only thing that they would own is if you get, let's say, funded research. Let's say you buy a computer. It depends, but I believe here at UNL, if I were to leave, I would have to give my computer back. When I was at Oklahoma State, I could take all my stuff from grants that I had, I could take it with me. But basically, you're somewhat getting into also the whole concept of intellectual property. And that's a big thing for people who are in academics. But like I own these lecture notes, for example. The university does not, which is weird considering they're paying me to do this. So, at a company, they would own it, but not in academics. The differences between industry and academics. So let's talk about another big topic, and that is the integrity of data and methods relative to ethics. A main point is the data that is observed is the data that needs to be analyzed. You might be thinking, well, of course. What else would I do? Well, that means, for example, you don't, let's say, remove some observations from your data set that will maybe make your new method that you're developing look better. Okay? So let's take a look at some examples of integrity of data and methods. First, obviously, falsifying data. Don't change observational values that you may have or throw out stuff that you may have. A very good or bad, depending upon in the context that I am meaning this, a good or bad example, I dealt with this researcher at Duke University a few years ago, where this made big news that him and his research team had developed some new cancer treatment methods that were going to revolutionize cancer treatment. Later it was found that, it's never been 100% proven, but people are pretty sure that he had actually falsified his data. And he's lost his job, for example, from Duke, and had other bad things happen. There's a nice little 60 Minutes TV show description about what happened there. It's an interesting watch. Okay, unusual and influential observations. Well, what do I mean by that? Let's take a look at a simple example that I would talk about like in a static setting course that does intro to regression. So let's say I have an independent variable, explanatory variable x, dependent variable y. And here's my data. So I have a nice little scatter plot. Those are all supposed to be little points. But then I have this other observation down there. Okay. If I were to draw an estimated regression model here, where would that go approximately, do you think? Do you think it would go right in the middle? If I were to use least squares estimation, do you think it would go right in the middle of those points? No. This guy right here is going to pull the line down. It's influential. It has lots of leverage, if you've heard that terminology before. For some reason, I lost all my toolbars here. So without that observation, I would have something like this. And, depending upon the context, maybe if we talk about in the context of, let's say, that you're doing consulting work, that maybe a subject matter researcher, meaning, let's say, somebody from animal science or brain science or finance or some other discipline, and you're working with them, they're having you actually run the regression analysis, and you point this out to them, and they might say to you, oh, can we just remove that? Because this is going to support my conclusions a lot better. No, you can't just remove that without some context. So, there are. So what can you do in those kinds of situations? Well, I'm sorry, I lost track of where I was. Well, maybe there's a different model-based approach that you could do that are robust to influential observations. And, you could use that, maybe instead of a least squares estimation, maybe you could use least median estimation. There's other methods out there. But one of the key things, though, is that let's say if you're writing this up in terms of a paper or even a homework assignment, is that you still have to mention this observation and its effect. Okay? You can't just totally forget about it and not let the reader know about it. Now, there are times where you could, let's say, remove the observations from the data. You could remove that observation. But again, you need to talk about that observation. Maybe, you're working with research and a researcher says, that can't be right for that observation to be there. There must have been maybe something wrong with my measurement tool, for example. Okay, that might be okay, but at least you need to talk about it. You can't just let the reader not know about it at all. You could leave the observations in. Okay. And even though maybe one's research hypothesis would not be able to be proved because of this, or maybe there's not as much strong evidence because of this, because the slope of the line is changing, you just have to deal with those consequences. There would be nothing wrong, though, with still talking about what happens if you did remove it. But, of course, you have to have some kind of justification for why it might make sense for this not to really be a true representation of what you're trying to model. So one example of where I've actually encountered this in practice is actually my very first paper I ever wrote. It just so happened to be also for chance. What I was trying to do, and if you take my Stat 75 class, you'll learn a lot more about this. What I was trying to do was estimate the probability of success for a place kick, like a field goal, a point after touchdown. In football, that probability of success as a function of a number of explanatory variables, such as the distance, such as measurements of pressure, and so on. I guess if you're in my Steady 850 class, you've heard me talk about that a little bit. But when I was trying to figure out what the best model was, this is when I was a master's student, I found two observations which were very, very, very influential. Okay? Now, when that happens, then you have to figure out, okay, or what you should do, is figure out, well, why are these so influential? And so I did some exploring. I found out they were influential because they were causing a particular interaction to occur. For football fans, it was interaction between the distance in the type of the place kick. Was it a PAT or field goal? So that's what they were causing that interaction basically to be in the model. Without those two observations, the interaction wouldn't be important anymore. So I had to think about what do I do? Well, there was a number of justifiable solutions out there. This is the one I chose. For football fans, you know that, and this was back in the days in the NFL when almost all point after touchdowns were just 20 yards. Now I think they're 30, 35. I don't remember. They've moved it back a little bit. But it was pretty much almost all point after touchdowns were 20 yards. The one time when it wouldn't be at 20 yards, if there was a penalty assessed due to something going wrong with the point after touchdown, that might move the PAT back to 30 yards, or maybe even move it forward a little bit. And so that's what this interaction term was trying to pick up. But since I had very, very few observations for those situations, I didn't feel as though I had really a good grasp about what's actually happening. Was this just an anomaly? Or was it a true effect that I was measuring here that was causing a difference in the probability of success when I had a non-20-yard PAT? So the approach that I decided to do was I decided to remove all non-20-yard PATs from the data set. Not just those ones that were causing influence, but all non-20-yard PATs. It was about like 10 or so. But I had to make sure and state that I did that in my paper. Also, I had to deal with the consequences, which was now my population of inference has changed. One cannot use my model anymore for these non-20-yard PATs because I have removed them from the data set. In the end, I didn't think that was a big deal because it, again, happens so infrequently. I thought my model would still be very useful. But I did definitely need to state what had occurred. Okay, are there any questions? This might be a good place to start. There is no questions then, and that's it for today.